In this video, we are going to study two reactions. One is Claisen condensation, another one is Dieckmann condensation. So first, we'll see what is Claisen condensation. In this reaction, two ester molecules are reacting, or we can say undergoing condensation reaction in presence of sodium alkoxide or any other alkoxide to give us beta ketoester. So let's see how the reaction occurs. We have an ester group, so here you have 3 hydrogens. Alright, this NaOR will give us alkoxide, that is OR negative. What it will do, it will eliminate one of the hydrogen. It will eliminate one of the hydrogen and it will get O negative. So you will be getting an enolate. This is enolate. This enolate will react with your another molecule of ester. And forming these pieces. Now what will happen? This will form a double bond and your OR negative will be eliminated here. Now there is one thing that you need to keep in mind. The alkoxy group attached here in your ester and in your base as well as another molecule of ester, these need to be the same, because esters have a tendency to undergo transesterification. In that, these OR keep on interchanging with each other, but if you will have two different alkyl groups in your base and ester, what will happen? You will get a combination of esters due to transesterification, and there will be a mix-up of products at the end of the reaction. So when you do Claisen condensation reaction, you have to keep in mind the OR group attached in the ester should be same as that of the base. Alright, now we have gotten this. Now what happened? There are two hydrogens present here. Alright, so OR negative will attack the hydrogen and eliminate it. So this carbon will have a negative charge. Now when you treat it with the acid, you will get a beta ketoester. This is your Claisen condensation reaction. Here you can have any other kind of esters or an aromatic ester also. But in short, it's an intermolecular condensation reaction of ester in presence of a strong base to give you beta ketoester. Now if you go to Dieckmann condensation, what is happening here? It's nothing but intramolecular Claisen condensation. In this case, it was intermolecular reaction. While in Dieckmann condensation, it is intramolecular Claisen condensation. Since it's a special case, so they have given it a different name, that is Dieckmann condensation. Now let's see what is happening here. We have a diester. This diester in presence of alkoxy will form a enolate. Now you have alpha hydrogens at 2 position. You can eliminate hydrogens from any of the 2 position. It doesn't matter because the compound you have taken is symmetric. So what is happening? It will result in the formation of OET negative, and this will attack the hydrogen. Sorry, not like this. It will attack the hydrogen and eliminate the proton. And your oxygen will have a negative charge. So this is enolate form. Now what was happening in this reaction? When you had an enolate species, it was attacking another molecule of ester, attacking the carbonyl carbon of that second molecule of ester. But in this case, what you have an ester group in the same molecule. And what happens when you have a possibility for both intermolecular and intramolecular reaction? Intramolecular reaction happens, because in order to undergo intermolecular condensation reaction, what happens? One molecule have to find the another molecule, but in the case of intramolecular reaction, the position where it has to attack has been attached to the same compound. So what is happening here? This ester group is transferred to the enolate form. So it will attack this carbonyl carbon, will attack your carbonyl carbon. So what is happening here? You are getting a 5-member ring. Let's count how. This carbon is attacking this carbon to form a cyclic compound. 1, 2, 3, 4 and 5. So you are getting a 5-member ring. 1, 2, 3, 4, 5. So if you see, the first carbon have a attached ester group. So I have written here ester group. On the 5th carbon you have O negative and OET. So that's here. Now what is happening? Again it will form a double bond and this will be eliminated. So OET negative is being eliminated here, and you are getting a beta ketoester. If you see, this is the ester group, this is the alpha carbon, this is the beta carbon, so you are getting beta ketoester. But in the case of Dieckmann condensation, your product is a cyclic beta ketoester, while in case of Claisen condensation, it's a aliphatic beta ketoester. In this case, 2 molecules are reacting, so it's an intermolecular reaction, while Dieckmann condensation is an intramolecular Claisen condensation reaction.